Trini?
That's what both rebelled.
Mm-hmm.
Really? Yeah, they're like.
Yes.
That's not having a real plan.
Yeah. You didn't bring the plan here. No, I'm sorry. You didn't bring a plan here.
What?
Excellent. Just put extras up the front.
That isn't a plan.
Phones away, laptops away.
Actually, my copy.
That doesn't count.
No. Why? For what? But education.
But you're actually
I don't. Okay. Once is fine. Torture is not managed.
Breakfast too. And then my partner was using this and I was so she's like, who's your
Aw, you can see the pink pen.
Test it out. Let's go.
Oh, you're
No, it's a UEG case, bro. It should never come. Like, watch it. It's very strong. Oh, shoot. It's on my phone. Can you please have it? Did it crack?
no questions asked.
Thank you.
This weekend I'm busy. Friday, so probably
I was there in the sun.
yeah. Do we do also?
It was so good.
No.
That's good.
It was so good.
You're not allowed to talk again.
Sorry?
Not you. Leo.
I'm not allowed what?
To talk again.
Your silence
Yeah.
signature.
What?
Nope, that's still talking.
What did I do?
Yeah, that takes over.
Keep plugged in. Oop. Ahem, gentlemen. Andrew. Gleb, put away your phone. Nick, laptops away. Kate.
Can you post this?
Focus. No, so you're normally on a pad thing. You're not ready to go. What?
I'm ready to go.
Normally, aren't you ready on your iPad?
Instead.
Oh, sadness.
She has the charger.
Sadness. It has died. We shall hold a funeral.
Kill a tree.
I do appreciate how I've set up the live stream, and now nobody on the live stream will be able to see this. Reset.
Don't you have like a camera at the top of your...
I do have a camera on the top of the thing.
So smart.
But can the camera... Don't think it can...
I think you can. You should have to move your setup.
Hold it.
Or just move the camera.
But then I'm going to have to totally set it up to do that. It'd be so annoying.
Very worth it for the people watching the live stream later.
Would it though, or is this just distracting things to take up more time?
No, I'd say it's better for the people watching the live stream.
Yeah, you would say that though, wouldn't you? Okay, let's shut that one off. Nope, that's awful. Oh, there we go.
No, add input. Let's go. Pop up.
Yeah, just add the camera input. Put it on like a box on the bottom right.
That's always interesting, yeah.
Oh, Brazil. She go crazy. Like really smart people.
Yeah.
I'm
Yay.
so smart.
Okay.
I don't know how to open up another. Yeah.
Go to OBS.
I'm in OBS.
Oh, you're in OBS, then you have to add a camera to OBS.
I added a camera.
Okay, and then you drag it to the
You got the camera on your screen.
Yeah.
Is it displaying on here?
Yeah. I could just drag this over there. But then, how do I get rid of all that? I've never done that before.
No, I mean like you can take this like the feed here into its own thing, but like you can just do that.
Yeah. Yeah, we could just do this.
So that works,
Yeah, that works. Yeah, let's do that.
and then you can just full screen it.
Yeah. There we go. Yeah. Whoa. Except it's got such a time delay.
Oh my god.
You gotta go to the OBS one to see the active feed.
Yeah, I'm not gonna know it all. Oh well.
Just go to the OBS and see the active
Good
feed.
enough. That's enough. Yeah, close enough. Okay. First one is the conduction of electrolytes in solution. What are electrolytes?
Something that conducts electricity with water.
Right. Why do they conduct electricity? What do they possess?
Ions.
Ions. So first one we're going to do, just so you're aware, I hate this demo. I've been shocked twice. When I was a child, worked on a farm, and they thought the funniest joke would be, oh, go just check that fence and make sure that it's working and close it up. And then when you do that, they forgot to tell you that they didn't shut the electrical fence off so that you shock yourself every single time. I'm going to do not glucose, sucrose. Will sucrose conduct?
No.
No, why not?
Because it's not ion.
It's not ionic. So hopefully it doesn't. But I have it dim in here so that we can actually see if it conducts at all. Any conduction? No. Okay, good. That makes sense. Life is making sense. Life is good. Oh, hold it. Which one of these? Pure water. Now, I'm also putting in pure water. Should pure water conduct?
No.
You're safe in a bathtub if you throw in a plugged-in toaster?
No.
No.
It conducts.
It conducts inside the back.
Not conducting.
Just kidding.
So why are you not safe in the bathtub?
So.
Because it's the toaster
Because
doing
water
the work.
isn't pure.
Well, this is the equivalent of the toaster. If that was conducting electricity, we'd see the light on. Pardon?
Because isn't the bath water not pure?
The bath water is not pure. This is staying pure because all it has is an electrode. You're a terrible electrode because you're constantly giving off grease and salt and like the sweat that comes. It will conduct relatively soon after you touch it. So even if you had a bathtub full of pure distilled water, and not to mention most water isn't distilled, it has stuff in it, which is healthier because you get some of your nutrients that way. Okay, next one. What do we got here? 0.1 molar citric acid. Conduct or not conduct?
Yes.
Okay. Why? What makes you think it's an electrolyte?
I got a feeling.
Got a feeling? I got a feeling. Obviously you can't see anything when I'm doing that, so. Oh.
Oh, there's a light open.
Oh. So it's on. Is it conducting super well?
No.
No. Citric acid, 0.1 molar. HCl, also 0.1 molar. Stop watching the screen. Watch here. Watch here. Go. Boom.
Damn.
Better or worse?
So much better.
So much better.
much
Wait, does
better.
that mean hydrochloric acid is
Again.
more ionic?
Okay, they're both the same molarity. So what gives?
Is it more
Cameras out.
ionic?
HCl and citric acid are both not ionic. They
Or, not ionic, more acidic?
HCl is more acidic.
Yeah.
No, but they're both 0.1 molar. How can it be more acidic?
Well, you know.
You know.
Because it is.
There's a recent topic that we've done. Pardon?
More hydrogen.
Yes. Why does one have more hydrogen if they're both 0.1 molar?
Because it's like the
Pardon?
Molecular structure.
that.
That didn't make sense.
Molecular.
But say it again.
No.
The structure.
What topic have we been doing since almost the beginning of the year?
Oh, wow.
Equilibrium.
Equilibrium. HCl is a strong acid, no equilibrium. All products. So you get 100, so if it's 0.1 molar HCl, you get 0.1 molar H plus and 0.1 molar Cl minus. So a lot of ions in there. But citric acid has an equilibrium. So if it's 0.1 molar citric acid, then you have some amount of dissolved just citric acid, not dissolved, not electrolyte, not separated, and some amount of H plus and some amount of the citrate ion. So we can tell that the acid is a lot stronger than the citric acid. And we can tell between the two, the ions in here are much less. So even though it's 0.1 molar, it's in an equilibrium, and not enough of them have moved over to the other side. Vinegar. Should that have a weak light bulb or a strong light bulb? Is that strong acid or a weak acid?
Wait, what was that?
Vinegar.
It's weak.
Yeah, it's weak.
You sure?
Yeah. Isn't like the more,
Well, like, compared to acid that can, like, burn your skin off.
didn't you say like the more sour it is, the more like base it is or something?
The more sour it is, the more acidic it is.
Oh, it is.
Acids are sour.
Oh, what's the other one?
Citric acid.
The more,
We use
Very
sour
weak.
candy.
Vinegar is so weak compared to citric acid.
I know.
It's not even. First of all, it's probably not 0.1 molar. The amount of in a vinegar solution you buy at the store is about 4%. I don't think that's even 0.1 molar. So it's a very, very weak acid. We know it's an acid. If you add it to baking soda or any other base, we know it reacts. But again, the equilibrium is such that most of it is just in its hydrogenated form. It has its hydrogen, so it's in its hydrogen form. Protonated form would be the best term. Now, it is glowing. I don't even know if you can see that. Very slightly. Get darker. Darker. No? Don't. Close the back door. Darkness. Now come up and behold the slight conduction.
I can see it from here.
No, literally, come on. I want you to see. Come here and look.
We can see it.
I
We
can
see
see
it.
No, come
I'm
here and
being
look. Walk.
I'm basically right here.
There. Once you see it, acknowledge it.
Yes. Right.
Acknowledge.
That's
Isn't
all.
that amazing?
That's all for you.
Amazing.
That's so,
So
cool.
cool.
I can't
So
see
cool.
For the rest.
like a little like small.
Yeah. So weak.
Wait, what is that? That's vinegar you said?
That's vinegar. And
So vinegar is slightly acidic?
That will definitely not pick it up.
maybe it will.
So vinegar is slightly acidic?
Yes, vinegar's an acid.
Oh,
Hold it. You didn't know that?
no.
What pH
Huh.
does it have?
You're one of today's lucky 10,000.
Yeah.
Newf, what
Yeah.
pH does it have?
Oh, I'd have to measure it. It's not very acidic.
It's like 6?
Yeah. I mean, honestly, I'd have to look it up.
Can we make it darker?
Yeah,
No, because then people just go to sleep.
No,
No.
it's
Yeah, they
not.
do.
It helps.
I have been in Mr. Snow's class when he is doing the thing, when the lights are low and he's writing the notes,
That's basically that.
and I've seen a third of the class literally sleeping.
Okay,
I
but you
wrote
talk.
so much notes.
Pardon?
You talk. So
doesn't he talk?
No, he doesn't. He just sits there and like writes.
Yeah.
He only writes.
Yo,
And he has
Listen,
really like
Phil.
sleepy
Please.
voice.
Okay,
that
no.
makes you go to sleep.
what?
Why?
Nonsense.
Google says
Citric.
vinegar is very acidic with a pH of 2 to 3.
What is?
Vinegar.
No, neither do I.
So gross.
I know, right?
My bad.
Who has
How? Oh, what? Look up. Maybe you can find it because I'd have to go measure it. I mean, maybe it is. Because that a point, a pH of 2 is what concentration? We did logarithms very quickly
Yeah.
the other day. So it would be 10 to the minus 2, so a 0.01 molar concentration. So it'd be 10 times weaker than this. So it's still pretty weak in,
Oh, so
in
this
a
is-
lab way.
This is a pH of
So this would have a pH of 1.
HCl.
HCl. So what would what would the pH of a 0.1 molar citric acid solution be?
No, wait, but Google says HCl has a pH of 3.
Yeah, that's because Google is stupid. What concentration of HCl? A solution of HCl is a pH of 3. It's a
pH?
0.001 molar solution.
Here, pH of 0.1 molar HCl
Has a pH of 2.
is in video.
Or don't watch the video. That's just silly.
Watch the video.
Don't watch
I'm
the
watching.
video. Okay. What's this one? Oh!
He listens to me.
Why did I turn off the light back on? I have one more.
Oh, it says 1.
Yay.
Can we keep the lights on?
pH of 1 is
Oh. Oh no, I'm talking. Okay.
Whoa.
I have the. By the way, if I do fall down after touching this and electrocuting myself, please call 911. Yeah. 0.5 and 0.1. So, this is now a strong acid, 100%, 0.1 molar. Bam. 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 0.5 molar. Brighter
Right.
or the same?
Same. Oh, same.
I'd say it's slightly.
No, the second one's brighter.
Second one's definitely. It's not much. It's only 5 times more concentrated, which honestly isn't that much. 0.5 molar versus 0.1. But you can definitely see that there's a difference. In fact,
Is this a solution that's like equilibrium or goes to completion?
so this is a strong acid. So let's. This one's a 0.1 molar. There's roughly over 100 mils in here. So add in like 10 mils. There we go. So now we have 0.5 molar. And it's also contaminated because I'm not rinsing it off each time. 0.1 molar, roughly 0.01 molar. Oh, gotta go. There we go. We get those ions in there. Stir. Hold it. Why did it go on for a second? Oh, there we go. So,
What is this one?
this is roughly 0.01 molar HCl. Now that we're getting down on concentration, we can see it's not just you can use it to tell the difference between weak acids and strong acids. You can also tell the difference between different concentrations of acids. If there's more ions in solution, it will conduct better and will conduct more electricity. At some level, you'll max out the light bulb, obviously, and that won't particularly work, but that is one way that you can do it. Now, of course, not everything that conducts is an acid or a base. What else could we add?
Salt.
Salt. So, I got back to pure water.
Wait, how'd you know?
Like that.
Good job, Kate.
What's weed?
I have
Oh.
some salt. Part of the problem is it's got to dissolve through, it's diffusing as it goes, but as it moves around, apparently it gets into an area that still has Come on, here we go. It's also got those little yellow things on the outside that sometimes trap the water. So it's conducting, salt conducts really well. This is salt soluble.
Yeah.
Yeah. How soluble?
Very solid.
Right. Sodium is dissolves with everything. So this is another one of those situations. There's no equilibrium there. If we put in something that had a very low solubility, it also wouldn't conduct because all the ions would be bound up. So weak acid, weak base, something with low solubility would have a similar weak light bulb if you tried to put it in. It may not even conduct it with something like iron 3 hydroxide, which is like KSP of 10 to the minus 39 or something. It may not conduct at all. So that was with something quite soluble. We have something else quite soluble, but is also either an acid or a base. Baking soda. What's the formula for baking soda?
That's a good question.
Come on, kitchen chemistry. What's the formula for baking soda? NaOH is lye. If you're using that in the kitchen, you are making, actually, I was going to say making death, but actually, you could be making bagels.
Lie.
Really? Do they boil pretzels with lye?
Yeah.
It's I didn't know that. I only learned that they did
That's
that
why
with
it
bagels
tastes
this year.
Wait, sodium
That's why they're
bicarbonate.
superior.
Well, it gives that crunchiness to the outside by the reaction. Interesting. Okay, I'm going to rinse it off. Put it in, hold it, I just made that one the distilled water. The electrodes are very there, pure distilled water. Baking soda, anybody find out the formula? You got some of you are doing notes and things with computers. What is it?
Sodium bicarbonate.
Sodium bicarbonate. So, should it conduct?
Yeah.
Yeah. Why?
Because it's ionic.
It's ionic. That's actually a trick question for the AP class, because they'll give them problems where does this conduct, and it's a very weak base or acid, which bicarbonate is. It's very weak, and you have to do all these mathematical calculations to show whether it has enough to actually conduct. But they forget about the sodium, and the sodium and the bicarbonate is a salt that's 100% soluble, so it immediately separates and provides tons of ions. And so actually the weakness of the bicarbonate doesn't make any difference at all. It dissolves right away and conducts relatively well. So to go back to, and away from this silly thing, I'm not entirely sure how useful that will be to absolutely anybody, is while I get this cleaned up, your job is to now color all the light bulbs with the amount of light they would give off relative to each other. Yes.
I did that.
How would we know sucrose?
Pardon? I literally showed it to you.
But I very like.
All of those examples I showed it to you.
But I forgot.
Oh, that sounds sad. Theo, do more homework.
More homework?
Do I?
What? My test was
You're
hard.
very targeted today.
You said the only thing I can't do is complain about my mark, and I won't.
Oh, yeah.
Theo?
Dentist.
Yeah.
Do your homework.
What did they say?
Yes.
Very targeted today.
I'm very what?
Targeted today.
Targeted? Who's targeting me? Or I'm targeting others?
Yes, you're targeted.
Yeah. It's probably all the coffee I've had.
Right, right. Citric acid was quite intense.
Can you do the sugar again, the sucrose?
Well, you can answer from first principles.
Still dihydrogenase.
Should sugar conduct?
It dissolves, but it's not ionic.
It's not ionic, so did you see conduction?
No.
So if it's ionic,
So it can only be an acid or ionic to have conduction.
Yeah, or
What is
a base.
citric acid?
if it's molecular, it will.
Which one was citric acid?
And well, in the same way that like vinegar doesn't conduct alcohol, you can have a weak base, it'll conduct a little.
What's citric acid?
No, citric acid was citric acid. Vinegar was vinegar. Yeah? Study more.
Which of the my mark is fine. Okay, wait, what?
Which one was red?
Actually, what are they called?
Oh, it's magic.
It says distill.
So citric acid.
All the water I used was distilled.
Right.
Yeah.
I say
Distill
this
dihydrogen.
goes a little bit.
Yeah.
That's the same thing.
How would
What's distilled dihydrogen monoxide?
Distill.
Yeah. And all the water, when I put it in water, that was distilled water.
So citric acid is that?
Distilled water?
this conducts more?
Well,
So
what was sucrose?
Sucrose is molecular. I don't know what would
and
conduct
this
more.
conducts you.
Wait, Glenn.
Yeah.
Would 0.5 conduct more than 0.1? Or other way around? Okay, what about citric? What about citric acid?
This one is very
We
No
can-
idea. I don't know how to tell which one would or which one wouldn't.
How acidic is citric acid?
very weak.
Like,
No, it wasn't as acidic as it
is
used
it
to be.
weak or acidic?
Google says it's a weak acid.
Well, how do you figure that out without
Acid.
Google?
Citric acid is a weak acid.
So it wouldn't conduct that much.
Google's
It would
not
be very
always
weak.
right.
Yeah.
But
It's
it's
not.
still conductive.
Yeah.
Yeah,
It's like a
You
very
get like a
light-
little bit of light.
Is that the one they use Lissa Walker?
No.
I think so.
No, that was the other one. That was like a really tiny one.
Is that like 0.1 HCl?
No,
No.
0.1 HCl still conducts a
That
lot.
was stronger than citric acid.
Yeah.
Oh, okay.
I think wait, Andrew's like this.
Is it strongest
It's
or
small,
Yeah.
then more, then even more, and then last sucrose.
Yeah. Yeah. I don't remember sucrose.
Sucrose is nothing. 'Cause it's not.
Sucrose is sugar, table sugar.
So,
And it's molecular. So it shouldn't be anything.
So citric acid just conducts a
Oh,
little
that's
bit.
just it. So look, here, plus and minus. Look at
the rest of
your.
So
I have one of the.
Distilled dihydrogen. Oh my god.
Okay, do you have your
Is that just
table?
water?
No?
So it did not conduct.
So.
So it's so much better
Everything
than
that is
mine.
non-metal.
So like how?
That is will dissolve and create anions.
way too much?
If you have, for example, sucrose, if you look at it again,
This room is so
Oh my god.
sucrose means
Oh.
what is this? What is C? Metal or non-metal? H. And then just basically,
okay.
and
So we should have pure water is a molecular solution. It has, as you'll learn, when I say it has no ions, I'm lying a little bit. It has a very, very small amount of ions. Because any molecular solution probably ionizes a tiny bit, but water especially we know does. But not enough to light a light bulb. It's not considered an electrolyte. 0.5 molar sucrose, again, molecular solution, no light. Or, have you ever considered, do lights emit light? Or when they're off, do they just suck in the darkness?
what?
When we shut off a light, maybe we're not shutting it off. We're turning it on and it's sucking in the darkness.
Okay,
But
but like,
darkness.
Yeah. So right now, you know, they're just, it's lighted. But if we turned it, they would suck in the darkness. That's why it would be darker at that spot. Anyway, regardless.
but like what
Oh,
about like
it
a place
doesn't
with
make
no
sense
light?
because
Pardon?
No light bulbs anywhere. It would be dark.
And maybe everything is sucking in darkness.
What about like outside?
Yeah.
But
Pardon?
Outside.
It says it in here.
There's a light bulb outside.
The sun. The sun is a giant darkness sucker.
that's true.
Hold it. No, I'm just developing a theory now. I think that works. Anyway, moving on because I'm going to distract myself. 0.5 molar HCl to 0.1 molar HCl, we can see that the amount of electrical conductivity relates to the concentration. So as you add higher concentration, it will conduct more and more. As well, if you have the same concentration, you can tell whether it is a weak acid or a strong acid by its conductivity. Strong acids will conduct a lot more than weak acids. They don't have an equilibrium. Now questions.
How do you tell if it's a strong acid?
If from this, it conducts more.
No, like how? You get like numbers?
Oh, you want to know how you would look it up?
Yeah.
Right. So go to your acid base table. These are all the strong acids.
Oh,
More the weak ones.
So the weak ones are all the ones underneath that are in the non-shaded section. Those, notice, what kind of arrow do they have?
One way.
One way, no equilibrium, 100%. So if you have a 0.1 molar HI solution, you have a 0.1 molar H+. Whereas if you have a 0.1 molar HiO3 solution, you do not have a 0.1 molar HI, you have an equilibrium problem to solve. So you now have to make an ice table. Where are the strong bases?
on the bottom.
On the bottom, which side, left or right?
Right.
Bottom right. So here's the strong bases. Is that all the strong bases?
No.
No. Most of the strong bases are missing from this table because this is an acid table, and most of the strong bases are things that just have hydroxide, like NaOH. So it is missing all of those ionic bases that have hydroxide. This is only dealing with the weak
Those are
ones.
strong bases.
So these are strong bases, and don't forget, all those are all strong bases, all the metal oxides. So metal oxide, also strong base, if that makes sense.
What's below also?
Metal oxide, also strong base.
Wait, so strong bases would conduct electricity?
Yeah, anything with ions would conduct electricity.
Anything with ions?
Anything with ions.
Typically, do ionic compounds conduct more than like most acidic ones, or like are there like a lot of acids that conduct a lot?
If you have more ions, you conduct more. So anything that's a strong acid, a 0.1 molar solution of hydrochloric acid will conduct the same as a 0.1 molar solution of sodium chloride.
Oh.
Because it's 0.1 molar and they're 1-to-1. But if you have something like sodium phosphate, Na3PO4, that dissociates 100%, then you get 4 ions for every 0.1 molar. That might conduct more because you've got more ions in there. So it just depends on the amount of ions. It also depends on the amount of positive and negative. So you only have one negative that has to move. But that one is -3. It's also bigger, so it moves slightly more slowly in solution. We don't consider all those factors. We're just going to, if it dissolves 100% or it's a strong acid or strong base, it conducts 100%. And all of the strong bases that conduct are soluble bases.
They're soluble?
Yeah, because if you have a hydroxide, I think iron 3 hydroxide has a very, very low KSP, not a strong base, because it does not dissociate. Whereas these ones, I believe, do. So, if you need to know your strong acids, you just have a list of them. Definitions. What's an electrolyte?
Something that has like sodium or something?
Yeah. What does it do? Conducts electricity. That's the literal definition of an electrolyte, is that it conducts that should be an I. I am leaving off some words. It's a solution in which it is dissolved that conducts electricity. So a metal isn't an electrolyte, but sodium chloride in solution is. So a non-electrolyte is literally does not conduct the electricity. For sport, they try to sell you things like Gatorade and Powerade and a variety of vitamin water, and they say that it has electrolytes. All they mean is it has some salts in it. None of them are very good for you. because they also add a ton of sugar. It's basically just a sugary drink with some electrolytes. You can buy ones that are just pure for sport that don't have a lot of sugar. But also you can just drink some water and then eat something with salt and potassium in it, like a banana. Yep.
Are we gonna have a J test? Or
Yeah.
quiz?
Yeah.
When?
It's posted.
March 1st.
There you go. Ta-da. What is, from last year, what does dissociated mean?
Far away from something, right?
Pardon?
This is
Not
this is
associated.
like far away from something, like separated.
It does mean separated. From Chem 11, what does it mean?
I don't remember.
We had two.
Oh, hey,
We had ionization and we had dissociation.
where you're extracting something? Is it like a titration?
Dissociated is something like NaCl going to Na plus. I'll review both terms then. Dissociated.
Decomposition?
Pardon?
Just a decomp? Like decomposition?
No, because that's not even a decomposition. They're the same thing. It's in a
That's just dissolving.
yeah. It's an ionic compound
We
separates into ions.
Only when it's ionic?
Yep.
And
We have a separate word if it's not.
what's that?
Ionization.
That's if something that's not ionic gets separated into two smaller non-ionics?
It gets separated into ions.
But how can a compound that's not ionic be separated then?
HCl. Non-ionic, but separates into H plus and Cl minus. Yeah. Non-ionic.
So, dissociation is the one, right?
So when you say that something is dissociated, it is separated into its ions. So instead of writing the definition, I sort of did it by example. Because if you don't remember the terms from grade 11, we're probably going to use them now.
Hi.
Hello. So HCl is a strong electrolyte. Practically, how do we know that? What's our laboratory evidence? Neha? The light came on. Not only just came on, but it was very bright. Light was very bright. That's how you test if something is a good electrolyte. You don't know the substance. You make a molar solution. You see how bright the light gets. If you want to be, if you're being particularly scientific about things, you'll measure the luminosity of the light. And you'll say, oh, that matches with another 0.1 molar solution that I also know dissociates 100%. And you can gauge how much it does. Strong electrolyte. Readily ionizes. And readily ionizes, we get 100% ionization. So we have a strong response. So the difference between a strong acid and a weak acid has to do with how much it ionizes. If it ionizes 100%, it is strong. If it's anything less than 100%, it is weak. Unless you are given 100% all the time, you are weak.
Does it say readily?
Hmm?
Does it say readily ionizes?
Readily ionizes, yeah.
What does that mean?
Readily ionizes?
Yeah.
Easily ionizes. Quickly ionizes. Ionizes with flare.
So it has to be 100% or else it's just weak.
Yep. If it has any equilibrium whatsoever, it's classified as weak. And then we'll use dumb terms, like that's a strong weak acid. Because English is weird.
No, I think that's just chemistry.
That could be. That could be.
But what about something like H3O? Like that's just like, just barely.
H3O? H3O plus?
Yeah,
That is acid.
I know, but it's like barely in equilibrium. would it be?
No, H3O plus is what acids make. So we don't talk about H3O plus as how much it maintains.
Okay, for example, like HIO3, that's also like, has a very small gradient.
Here, let me
Would
just
that be weak?
let me do this as an aside, because this is a definition thing. HIO3, yes. Is that? Yep. Yes. No, that was the one you wanted. What was your question about it?
No, I was just wondering, like the ionization of HIO3. It's like barely in an equilibrium, so would it be weak?
Oh, yeah. It's KQ is or KA is 1.7 times 10 to the minus 1.
So that's like kind of high. That's like
Yeah, but it's not 100%, so it's weak. You would say it is a strong weak acid. Because there's no such thing as a weak strong acid. If you're a strong acid, you're 100%. Boom. But you can have different relative strengths of weak acids, and as you've noticed, the higher up they are, that Ka gets a larger and larger number. That means you have more and more of the products, which means it's a stronger and stronger version of a weak acid. Yep. So yeah, the table is arranged by strength. Write the equilibrium for HCH3COO. Write it with water. I haven't done attendance yet. Where's my?
You just move one of the H's over.
We did, yeah, we did it last day. Andrew, Ashley, Ella, Etienne, Gleb.
Are we gonna have
Josh
to
is
do that
not here.
A test before?
Right, I'm not going to talk about tests right now. Talk to me at the end. Katie, Lavina, I don't see. Max is here. Nathan is here. Neha's here. Nicholas is here. Sam, I don't see. Sonia,
Sam is sick today.
Theo. Pardon?
Sam said he was sick today.
Yeah, I'll check the actual attendance in a moment. I'm just taking the quick attendance. 10, Ashley. And Sonia's leaving early. How dare we?
Yeah. There's 8 beans and
Okay.
8 beans and H.
Don't just ignore her. She's leaving. Shunned. Shame.
Wait, so what?
Gleb,
How do you know to?
do it for everybody.
Yes.
What do I write?
Oh, I thought it had to come up. That's fine. HCH3COO plus H2O.
I wrote it right first.
And then a double way
Sorry.
thingy. H3O plus CH3CO minus.
Yeah, and from last day, here's our conjugate acid base pairs. So our conjugate acid base is acetic acid and acetate. This is a base, that's an acid. It is a weak electrolyte because we have an equilibrium.
What about the equilibrium?
If you have one, it is a weak electrolyte. It is not 100% dissociated. Yep.
Yeah.
Which part?
The H3O.
Oh, just writing the equation?
That one was like that.
Yeah. 'Cause
We
like
did-
last part, we just, like I get the first part, just like plus H2O.
Yep.
But then after that, shouldn't it be like, something plus OH minus?
7 something?
No, something minus OH minus.
That's for bases. This is an acid, right? So if you have an acid, you have a proton donor. So what's happened is the proton has been donated to the H2O.
Yeah.
So proton is H plus. So we added the H plus, so the sign changed. We added an extra hydrogen, and now this one's missing a hydrogen and missing a positive charge. Yep,
Wait, it says not 100% disassociated.
yep,
Is that just
because we have an equilibrium arrow.
So like, if we were given a question like in the example, and we're supposed to like write the equation, how do we know it's going to be an equilibrium, or how do we know it's going to?
If it's not a strong acid, it'll have an equilibrium. And you have a list, and they're at the top. In fact, look up on your page, what's the Ka?
Very large for all.
No, 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 for this one.
Oh. Hang on, let me find it. Oh, like 6.4, 10 to the negative 5.
I'm assuming you figured out the right one.
1.8, 10 to the negative 5.
Sorry, 1.8?
Yeah.
Okay, 1.8 times 10 to the minus 5. What is a KQ generally? What over what?
Products, so concentration of products over concentration.
Yeah, products over reactants. So it's these divided by those multiplied together. If you have 1.8 times 10 to the minus 5, that means you have a fraction that is roughly 1 over. So most of vinegar is staying in that form. A very small amount of it is coming out and affecting it. Now, if you reacted this with a base, what would happen to that? So I dropped in some OH minus and sodium hydroxide. What would happen to the amount of H3O plus? It would increase?
Or it would
No, it decreased.
It decreased. Yeah, OH minus plus H3O plus would go to 2 waters, or the classic grade 10 way, I'm just writing the top one to get used to grade 12, is that that would be H plus, and you get water. And you'll notice that your table's written as if they don't add water to every one. It just makes the table bigger, and so they just assume you know how to do that, and they just make it, that goes to H plus that. But that's the reaction that's actually happening. And so it's a 1 to 100,000 ratio, roughly. So very little of it is acidic. But if you start adding base, all of it's available. So it can still move over until it's completely gone. So if you have some base you need to use up, or some acid you need to neutralize, using a weak base is just as effective as using a strong base. All of it can be used, and once it stops reacting, it just will be a weak base again. So if you have an acid spill, the safest thing that you can, I don't have it in here anymore, that you can treat it with is baking soda. Because even if you add too much baking soda, at the end you just have baking soda. It doesn't dissociate that much. Whereas whatever acid you're doing is strong acid, which is, if you did it with a strong base, it would dissociate 100%. And if you overshot it, you would have all this strong base lying around. So equilibriums are really useful because not all of it is readily available, just enough to start reacting. Strong acid, strong base. We've kind of already done this because you asked really good questions. Write down all the strong acids and strong bases. Now for this one, I want you to write down more than what's on the table. So you should get the ones that are on the table, but I want more than what's on the table. Strong acid, strong base, put a definition here since I have room, reacts. Completely. In water to form aqueous ions. 100% ionization or dissociation.
Is that for strong acid or strong base?
Pardon?
Is that for strong acid or strong base?
Both. Yeah. There's not nearly as big a list of strong bases that aren't just metal hydroxides. Yep.
What does that word say at the start of the sentence?
Reacts. Do I want to test recognize that? And no, I don't. I don't want to test recognize that.
So why does the K have to be strictly not in equilibrium?
If it's products over reactants and 100% react to become products, what would the Ka be? That says rinse. Very glad you asked. I asked you a question and you just said, If 100% of it went to products, and equilibrium's products over reactants, how many reactants do you have?
0.
0. What's a number over 0?
0.
No.
Oh, it's just that number. Wait. 1. Undefined.
It is undefined. Or, when I'm having an argument with Ms. Walensky, infinity. Because if it completely dissociates, and you get like 0.1 molar, so it's 0.1 molar of H3O plus, and there's none left to begin with, how many times can 0 go into 0.1?
0. Well, it doesn't.
Well, I mean, it can go into it forever. Yeah. So in one sense, it's infinity. That's why all of these say very large. Because if you do this with like calculus, don't say it's 0. Say it's a number really close to 0, like 0.000000000000001. What does that number become? Very big. A number divided by a super small number gives you a very big number. So whenever you see a number over 0, that's a really, really big number. Whatever it is. And then scientists do weird things with it. You've used like numbers like, obviously you've used pi, you've used e, natural log of 2 in your math classes. You hate e? Yeah. Hate e. We were doing I was in physics at university, we were doing a lab, and we realized one of the variables or constants we had no way of knowing. And we asked the professor, what could we use for that constant? Like, we don't know, what should we use? And he said, oh, use e. And I was like, but it's not e. And he goes, yeah, but it's a small number. And e's kind of a small number, so it'll work, just use that. And I said, but that's wrong. And he says, no, it'll work, trust me. And it worked. For some calculations, it doesn't matter. I found out for astronomers, pi is equal to 10.
What?
Yeah. Because at the scale they're using, it doesn't matter.
What does that mean?
The difference between 3 and 10 is nothing.
So could it just be like 5, 2?
Yeah, yeah. But if it's 10, you could just move the decimal place. Really easily.
Why are they just making your number
Pardon?
pi?
What?
Why are they just making your number that isn't pi? Or like completely changing it?
Oh, they make it 10 to make their calculations easier, so they can do it in their head. I mean, when they write a paper, they'll use the proper number. But when they're doing quick calculations, it's just 10. If you're an engineer, you make it 3. Okay. There we go. You've written down all your strong acids and strong bases. Great. Write down 5 on each side. Weak acids and weak bases. And then I'm going to ask you. for your weak bases, at least one should not be amphiprotic.
What?
What's that?
What's an amphipotent? Is
That's
that
it.
like some kind of
That's
amphibian?
that should be that's last days. So what is amphiprotic?
Amphipotent?
Yep.
Not a proton.
No. But sort of like the opposite of that.
Amphipotent.
Amphiprotic.
Oh, protic.
Protic.
Protic. I heard
Protic.
So
protic.
like positive something?
Pardon?
Positively charged?
Nope.
Oh, it's like
What's amphiprotic?
it can give and accept.
It can give and accept. Twice the chance of a date on a Saturday night. It's got an H and it's got a minus. So there is exceptions, which we also went through last day. So there is one notable exception you'll find in your table if you pick it. If you have a negative charge, then you can probably accept a proton, and now you can be H2X or some variation thereof. And you have a proton that you can give away, so you can also be an acid. So an amphiprotic is both an acid and a base, depending on its partner or the strength of its partner.
Wait, can ions be amphiprotic?
Yeah, in fact, they have to be negative.
What about molecular compounds?
They often are molecular compounds.
Oh,
Almost all, I mean, HCl, strong acid, is a molecular compound. HCO3 minus, which is bicarbonate, which is amphiprotic, is a molecular compound. A lot of them are covalently bonded. The only time you find the ionic ones are like sodium hydroxide, and they're all strong bases. A lot of the weak ones are molecular compounds. They're just also acids.
Wait, Mr. Neufeld.
1 second, I have to ask Andrew. Andrew, what does amphiprotic mean?
You said it gives off one negative charge?
It often has a hydrogen charge, but what is its definition? What is it?
It gives a charge to the other.
What?
Yeah, it gives or accepts like protons. Yeah, protons.
I heard Taz.
But I said it.
That's fair enough. Okay. Do you have your question?
Why is NaOH a strong base?
What does it give off?
fair enough.
OH?
Yeah. And last day I had you write equations that were, if you were doing bases, that looked like this. If you had CO3 minus 2 plus H2O goes to HCO3 minus plus what would be the natural OH minus. Every single base makes hydroxide. Hydroxide is what base is. Not all of them have to have hydroxide, they just make it by taking away a proton from water.
What's a weak base that's protons?
That's a weak base, because this goes both ways.
And NaOH doesn't.
NaOH, as we know from our this is why we do solubility before this. Is that at equilibrium or 100%? No, I'm asking you, is it 100% or an equilibrium?
100%.
100% because it's sodium.
Yeah.
Gleb,
How do we know what's a strong base without the table?
you memorize the table?
Without the table?
Yeah, or experimentally in the lab.
Why'd you say we need to find more than it?
Oh, I see what you're asking.
You said
What
we should
is
find
this a
more.
strong base?
I mean, yeah. But that's just one. You said one.
Yeah, you should be able to count with multiple ones. So knowing that this is a strong base, give me another one.
How'd you find NaOH?
Oh,
There you
I
go.
see.
There you go. Yeah.
How'd you find NaOH? For the
You-
weakness?
It's not a weak base.
It's not a weak. It's strong.
Yeah, wait. I don't see it on the thing.
It's not on the thing.
I just have to know that?
Yeah.
Oh.
All the metal hydroxide have the potential to be a strong base if they ionize 100%.
So would NH4OH be a strong base?
Yes. NH4OH is a weird one. It would dissociate 100%. You have hydroxide, but what's NH4 plus? A weak acid. So that would react, make water, and give off ammonia, which is a weak base.
Okay.
Yeah. Okay, let's just go around the room. Starting here at Ella. Give me a couple strong acids.
Okay, HClO4. You want more?
Yeah, 2.
Oh, HI.
Okay, keep going.
Strong acids.
Yeah.
HBr and HCl.
Keep going. Excellent. Nia, keep going.
I found the same ones.
Pardon?
I found like the same ones.
No more? Okay, strong bases. There's 2 on your table. Where'd you find them?
Wait, did you say acid or base?
Base. Strong bases.
Okay. NO3. NO3.
NO3? You're looking at the wrong, I think you're looking up here.
Yeah.
Those are incredible. They can't even go backwards. Those are the weakest of all bases. So all the way down to the other end. You'll find a couple right there.
Oh, okay, wait, I was looking at the wrong side, yeah. Okay, so NH2
NH2 minus?
plus H.
Nope. Just that's a strong base. If you do plus H, now you've neutralized it.
Okay.
So remember, these are written as acids. So that's why we would put the plus H. What's the other one? O2 minus. There you go. So I'm going to ask for more, now that we've exhausted the table. 2 more strong bases.
KOH,
KOH.
NaOH.
Excellent. NaOH. Gleb, keep going with strong bases.
NH4OH.
And, no. For reason.
You literally said that was a strong base.
NH4OH would dissociate, and I explained it, into this, except that's an acid, which would react with that, leaving H2O plus NH3, which is a weak base. So it is a weak base in disguise.
TBOH.
That is.
RBOH.
Oh, that'll work.
FR.
Just two. What?
CSOH.
CSOH. Okay, and I'm going to ask Andrew 2 more, but no alkali metals.
OH minus?
Yeah.
Oh, you're dead. You're done.
Just move over one.
SR.
SR what?
2 plus. OH.
It's got to have hydroxide in it.
OH.
Yeah, OH.
Yeah. Yeah. It's soluble. Yeah.
Anything that's
Anything that's soluble will work.
I have a
Yeah.
question.
Actually, I don't know if there are 2 more. Because NH4.
You can do HOH.
OH4.
No, that's just water.
Oh,
Yeah.
wait, NH4OH.
Clever. However, let's see.
Why doesn't NH4OH work?
Because it's NH4 is a.
Calcium hydroxide. They don't have them here. So that would work as well.
I have a question.
Yep.
Oh.
Why are weak acids
We do the same thing.
weak even though they're fully soluble?
They're,
Like for example,
Uh,
H.
for it to be strong,
Yeah.
it has to dissociate, turn into ions, 100%.
Yeah, but why? For example, HSO4.
Yeah.
If you look at the solubility thing,
Yeah.
it says fully soluble with SO4 and H.
Wait.
Yeah, it will dissolve.
Yeah.
So you can have, I see what you're asking. Yeah.
That's actually
Because you can have HSO4
Yeah.
aqueous, not separated, just aqueous. In the same way that glucose can be dissolved.
So it's weak acids or strong bases. The strong bases you have to add the H to it.
Is that good then?
I mean, what about H2SO4?
Well, it's a strong acid, 100% dissociate into
That's a
that.
strong
specific-
acid.
Yeah.
Okay.
Okay. With some weak acids. Des.
NH3. Right?
No. It goes up there, but that's not where it goes. Where'd you find NH3?
At the bottom.
It's at the bottom.
Yeah, and it's in gray. What does that mean? What side of an arrow is it on?
Oh, shit. Hold on one sec.
You said
Yeah.
acids.
Let's go with H2O2.
H2O2. That works. So one of the problems, if you pick the extremes of the table, you're either picking something that's not it and can't be it. So down here, these acids are all the strong acids. These are all the things that are not acids. They can't go backwards.
So HPO4 2 minus would work.
HPO4, 2 minus would work. Yeah. Theo, give me a couple more.
No, I have a question.
Nope, no more questions. I want to finish this.
Okay. Well, H2SO3.
H2SO3. What the heck just happened? Oh, I zoomed in. There we go. Sorry, what'd you say?
H2SO3.
H2SO3. Good.
But that's my question. Why does that work?
Pardon?
Why does that work?
What do you mean, why does that work?
It's on the solubility chart and it says soluble.
Yeah, it's soluble. There.
But it doesn't have a charge.
It doesn't have to have a charge.
What?
When you dissolve glucose, what happens?
I thought you needed a charge.
Yeah. Just what happens when you dissolve glucose. Stop touching the board, Mr. Dufault. What happens when you dissolve it? Does it change into ions?
No.
No. It just goes from solid to aqueous.
Sure.
It just does that. And also, keep in mind, your solubility table is a very simplistic table. It's not going to get into that sort of thing. We're doing that now with acids and bases. So now you know that that's possible. Give me one more.
Acetate.
Formula?
CH3COOH.
Good. Nicholas, give me some weak bases.
BeOH2.
No weak base. Oh. From the table. Andrew, Tess?
That's only OH. Would OH be?
Pardon?
OH.
OH minus?
Yeah.
That's the strongest of all bases. That is a base.
I have a strong base.
What? I don't want a, I want a weak base.
I mean, I have only just answered this.
And you've already answered.
HPO4.
HPO4. What's the charge?
2 minus.
2 minus. Give me another one.
Isn't that?
Good.
H2O2.
Which side are you finding that on?
You have that up as
There's an acid side and there's a base side.
Then the HPO4 is on the acid side as well.
It is also, if you look down next to the number 6.2 times 10 to the minus 8, you can find it on the base side.
Oh, what? So, wait, how is that possible?
Ah. I'm going to ask Andrew that question in a moment.
What?
Yep.
Wait, what do you say?
You see how it's HPO?
Say H2.
Okay, while you're looking at more bases, bases from you as well.
IO3 HC2O4
HC2O4, what charge? Minus?
minus.
Okay.
HSO3
HSO3 minus, okay.
SO4.
SO4 minus 2, okay.
And
F minus. Yep, that's weak. Okay, Nicholas, one more.
yeah, let's do HS minus.
HS minus, that work.
Would I minus work?
I minus would not work.
Why?
It's on the opposite side of a one-way arrow. It cannot go backwards, so it cannot act as a base. Its conjugate acid is strong. So if you're the conjugate base of a strong acid, you have no life. You cannot be yourself. This is like being the spouse of a movie star. Nobody cares about you. No one calls you, you know, well, look, it's so-and-so. They say husband or wife of. Right?
That's never fun.
Yeah, yeah. For all of, now, this is on both sides. Andrew, how can this be on both sides?
Soluble.
A good guess? Nope. It's a new word you just learned. Starts with A. If you get it, everybody can go for earlier lunch.
Amphibian.
Nice.
Yes.
How did that happen so fast?
Because I wrote it down. I wrote it down.
I was not expecting it. I thought that was going to at least take 3 minutes.
I'm a genius. Don't look at that.
I wasn't actually expecting that earlier. Nicely done, Andrew.
Thank you.
Yeah, it does that. Well, I wouldn't know.
I'm like walking out like I'm the president.
Oh god, we left 5 minutes early. Like,